Hi listeners, I'm Nandhakumar, Assistant Professor, Department of Computer Applications, AJK College of Arts and Science. Our subject is Linux operating system. Let us start with the introduction. See, first we should know about these softwares. What are the types of softwares? There are two types of softwares available. One is system software and another one is application software. What's meant by system software? System software which acts as an interface between the software and the computer hardware. See, these are all the examples of system software. Windows, Linux, Unix. These are all the examples of system software. Then what are the application softwares? Office, MS Office, Photoshop. These are all the application softwares. First, it starts with the introduction. Operating system is a program that acts as an interface between the software and the computer hardware. See, the operating system is an integrated set of specialized programs that is used to manage the overall resources and operations of the computer. Because the operating system acts as an interface between the hardware and the application software which is installed by the user. It is a specialized software that controls and monitors the executions of all other programs that reside in the computer, including the application programs and the other system softwares. Next, here's the diagram. See, this diagram clearly explains about the operating system. See, first there is a hardware that we use to install the operating system, example the Linux, Unix, whatever it may be, Windows. And then in that operating system, whenever we install the application software, it lies between the operating system and the hardware. The last one, that is the user. The user will work on the application software. See, this diagram clearly explains about the operating system. Next, the major OS management tasks are. These are all the operating system tasks. First one is processor management. The processor management involves putting all the tasks into order and it performs the task one by one. Next, memory management, which coordinates data to and from the memory and determines the necessity for virtual memory. Next one, device management. Device management which provides interface between the connected devices. See, what are all the connected devices are available in our computer? Example, the printer, monitor, keyboard, these are all the things, mouse. Next one, storage management, which directs permanent data storage. Storage management is nothing but which manages all the storage devices. What are the storage devices? Hard disk and other external devices. Next, applications, which allows standard communication between software and your computer. That is the application. Next, user interface, which allows you to communicate with your computer. See, the last one is very important thing. So whatever the software we install in our computer, finally in that software the user interface is very important thing. Next, the major functions of operating systems. The first one is it boots the computer. Without an operating system, we cannot boot our computer. It performs basic computer tasks. Example, managing the various peripheral devices. Example, mouse, keyboard, printer, these are all the peripheral devices. It manages all the tasks in the computer. It provides a user interface. That is the command line, graphical user interface. See, the GUI based OS is Windows operating system. It handles system resources such as computer's memory and sharing of the central processing unit, time by various applications or peripheral devices. Next, it provides file management. Definitely, the main purpose of operating system is to manage the file management. Okay, it stores, retrieves, and saves the data. Last one, the error handling is done by the operating system. It takes preventive measures wherever required to avoid errors, such as warning messages. These things are called errors. Next, let us start with Linux operating system. Linux is an open source operating system It is like Windows, Mac, OS, Android, etc. Linux is one of the popular version of Unix operating system. It is an open source. As it is, source code is freely available. It is free to use. See, the Linux is a kernel. It is a clone of Unix operating system. Okay. The Linux was designed considering Unix compatibility. Its functionality list is quite similar to that of Unix. See, the functions of Linux operating system is more similar to Unix operating system. See, these are the components of Linux operating system. If Linux operating system has major three components, the main important component is kernel. See, in every operating system, the kernel plays an important role. See, kernel is nothing but it's a core part of any operating system. It's same as in Linux. It is responsible for all major activities in operating system. It consists of various modules and interacts directly with the underlying hardware. See, the kernel provides the required abstraction to hide low-level hardware details to system or application programs. See, as I told earlier, the kernel plays a major role in an operating system. Next one, the system libraries. See, the system libraries are the special functions, or we can say it's a special programs using which application programs or system utilities accesses kernel's features. See, the libraries implement most of the functionalities of the operating system and it does not require kernel modules code access time. See, every operating system, the libraries plays a vital role. Next one, system utility. The utility programs are responsible to do specialized individual tasks. These are the utility programs which is used to perform some specific task. Next one, see the major difference between the kernel mode versus user mode. See, here we are going to discuss what's meant by kernel mode and then the user mode. Kernel component code executes in a special privileged mode called kernel mode. See, it has a full access to all resources of the computer. The kernel mode has a full access rights to access all the resources of our computer. This code represents a single process. It executes in a single address space and it does not require any context switch and it is very efficient and fast. The kernel runs each processes and provides system services to processors. It provides protected access to hardware to processors. See, I already told you the kernel plays an important role in operating system. Here, the kernel provides a protected access to hardware to processors. Next one, support code which is not required to run in kernel mode in a system library. The user programs and other system programs works in user mode. See, here the other thing is user mode. User mode, the system programs works in user mode. The computer programs, all the computer programs works in user mode, which has no access to system hardware and kernel code. Example, the user programs and the utilities use system libraries to access kernel functions to get system's low-level tasks. See, here is the Linux system architecture. So this diagram shows the structure of Linux operating system. See, in the diagram, the highlighted point shows the hardware, kernel, shell, and then the applications, utilities. See, these are all the major things are available in an operating system. Not only in Linux, in all operating system has some own structure. See, these are all the contents which we have seen in the diagram. An operating system is a collection of software is designed for a specific functions. This we already discussed in the previous section. See, the Linux operating system has following components. See, these are all the major components available in Linux operating system. The first one is kernel. We discussed earlier. System libraries, system tools, the development tools, the end user tools. See, we discussed one by one. The kernel, I already told you, this is a core part of operating system. It establishes communication between devices and the software. Devices means hardware and other external devices and the software. Moreover, it manages the system resources Basically, it has 4 responsibilities. The kernel has 4 responsibilities. First one is device management. It manages all the devices which is connected with the CPU, that is memory device, sound, graphics, printer, everything, etc. The kernel stores all the data related to all the devices in device driver. See, in a computer, the device driver is more essential thing. So, what is meant by device driver? See, for example, if you are installing a printer, we cannot directly access the printer in our computer. For that, we need a device driver software. Thus, that device driver software helps us to communicate the external devices to our system. Next one is memory management. The another function the kernel has to manage is the memory management. Kernel keeps a track that is used and unused memory and makes sure that processors should not manipulate data of each other using virtual memory addresses. That's the memory management one. Next one, it processes all the process management things. The process management kernel assign enough time and gives priorities to processors before handling CPU to other processors. It also deals with security and ownership information. The process management, what's meant by process management? See, whatever the process which is executed by our computer, a process will be executed one by one. Each process is assigned a time. Based on the time, the process will get processed. Next one, handling system calls. Handling system calls means a programmer can write a query or ask the kernel to perform a task. The programmer can write a query and he can ask the kernel to write a task. Next one is shell. This is a major important thing in Linux operating system. See, our subject is Linux and shell programming. So shell is most important thing. See, the shell is an interface between the user and the kernel. And it affords services of the kernel. It takes commands from the user and executes kernel functions. See, the kernel, it takes commands from the user and it communicates or executes kernel functions. The shell is present in different types of operating systems, which are also classified into 2 types, that is command line shells and graphical shells. Command line shells which are executed by commands. The next one is system libraries. The system libraries are special programs that helps in accessing the kernel's features. The kernel has a trigger to perform a task, and this triggering is done by the applications. But applications must know how to place a system call, because each kernel has a different set of system calls. Programmers have developed a standard library of procedures to communicate with the kernel. Next one is system tools. The Linux OS has a set of utility tools which are usually simple commands. That's a system tools. Linux mostly use simple commands. Based on the commands, we have performed several tasks. It is a software which GNU project has written and published under their open source license, so that software is freely available to everyone. See, already I told you, the Linux is open source software. It is freely available software. All the users can easily access Linux operating system. The user can easily understand as well. With the help of commands, you can access your files, edit and manipulate your data, and the directories or files. We can change the location of files or anything. Say, whatever the tasks we perform in our system, we can easily perform with the help of commands. Next one is, Linux provides more security than Windows operating system. Mainly, the Linux is used in network fields. Development tools. With the above 3 components, our OS is running and working. But to update your system, you have additional tools and libraries. These additional tools and libraries are written by the programmers and are called tool chain. See, the tool chain is a vital development tool used by the developers to produce working applications. See, the tool chain is used to produce a working application. End user tools. These end tools make a system unique for a user. End tools are not required for the operating system, but it is very useful to the user. Some examples of end user tools are graphic design softwares and office suites, web browsers, multimedia players, etc. Next one is open source operating system. Most OS come in a compiled format, means that main source code has run through a program called compiler that translates the source code into a language which is known as to the computer, which is nothing but the source code which is compiled to machine code. Modifying this compiled code is really a tough job. On the other hand, open source is completely different. The source code is included with the compiled version and allows modification by anyone having some knowledge. It gives us freedom to run the program, freedom to change the code according to our own use, freedom to redistribute its copies, and freedom to distribute copies which are modified by us. So this is called an open source operating system. Next, Linux history. The first thing is, I already told you Linux is a clone of Unix. First, we should discuss the evaluation of Unix operating system. In 1969, a team of developers of Bell Labs started a project to make a common software for all the computers and named it as Unix. It was a simple and elegant. It used C language instead of assembly language, and its code was recyclable. As it was recyclable, a part of its code, now commonly called kernel, was used to develop the operating system and other system functions, and it could be used on different systems. Also, its source code was open source. Initially, Unix was only found in large organizations like government, university, or other larger financial corporations with mainframes and mini computers. You see, it's a microcomputer. See the expansion of Unix. In 80s, many organizations like IBM, HP, and dozen other companies started creating their own Unix. It results in a mess of Unix dialects. Then in 1983, Richard Stallman developed GNU project with the goal to make it freely available Unix-like operating system and it to be used by everyone. But his project failed in gaining popularity. Mainly, many other Unix-like operating system came into existence, but none of them was able to gain popularity. Then, a new project that is called the evaluation of Linux. In 1991, Linus Torvalds is a student at the University of Helsinki, Finland, thought to have a freely available academic version of Unix, started writing its own code. Later, this project became the Linux kernel. He wrote this program specially for his own PC as he wanted to use Unix 386 Intel computer but couldn't afford it. He did it on Minix using GNU-C compiler. GNU-C compiler is still the main choice to compile Linux code, but other compilers are also used like Intel C compiler. He started it just for fun, but he ended up with such a large project. Firstly, he wanted to name it as Fritz, but later it became Linux. See, this is the history of Linux. He published the Linux kernel under his own license and was restricted to users commercially. Linux uses most of its tools from GNU software and are under GNU copyright. In 1992, he released the kernel under GNU General Public License. So, Linux is a kernel. Now, the Linux are used in supercomputers, smartphones, desktop, web servers, tablet, laptops, and home appliances like washing machines, DVD players, routers, modems, cars, refrigerators, etc. These are uses Linux OS. Next topic is the features of Linux. Multi-user capability. Multiple users can access the same system resources like memory, hard disk, etc. but they have to use different terminals to operate. Next one is multitasking. So like Windows, more than one function can be performed simultaneously by dividing the CPU time intelligently. Next one is portability. Portability doesn't mean it is smaller in file size or it can be carried out in pen drives or memory cards. It means that it supports different types of hardware. See, portability means we can easily carry anywhere. That's the general meaning. Security. It provides more security. It provides security in three ways, namely authenticating, authorization, next one is encryption. Live CD and USB. Almost all Linux distros provide live CD USB so that user can use it without installing it. Next, graphical user interface, that's the X Windows system. Linux is command line based OS. It can be converted to GUI based by installing packages. It supports customized keyboard as it is used worldwide, hence supports different languages keyboards. Next, application support. It has its own software repository from where users can download and install many applications. Next, main important thing is file system. It provides hierarchical file system in which files and directories are arranged. Finally, the Linux is open source software. The Linux code is freely available to all and is a community-based development project. Next, why we use Linux operating system? Linux is completely different from other operating systems in many ways. It is an open source operating system which gives a great advantage to the programmers as they can design their own custom operating systems. It gives you a lot of option of programs having some different features so you can choose according to your need. See, the global development community look at different ways to enhance its security. See guys, the Linux provides more security than other operating systems, hence it is highly secure and abused, so you don't need an antivirus software to scan it regularly. Companies like Google, Amazon and Facebook use Linux in order to protect their servers as it is highly reliable and stable. In general, maximum all the software companies uses Linux. Above all, you don't have to pay for software and server licensing to install Linux. It is absolutely free and you can install it on as many computers as you want. It is completely trouble-free OS and don't have an issue with viruses, malware and slowing down your computer. See, next, Unix versus Linux. Today, Linux is a great demand. You can see the use of Linux everywhere. It is dominating on our servers, desktops, smartphones, and even used in some electrical devices like refrigerators. Some people think Unix and Linux are synonyms, but that's not true. Many operating systems were developed to be like Unix, but none of them got the popularity as Linux. Next, Linux distributions, that is called distros. Other operating systems like Microsoft combine each bit of codes internally and release it as a single package. You have to choose from one of the versions they offer. But Linux is different from the different parts of Linux or developed by different organizations. We discuss the Linux distributions in the next section. The different parts include kernel, shell utilities, X server, system environment, graphical programs, etc. See, these are the Linux distributions list. Ubuntu, it came into existence in 2004 by Canonical and quickly become popular. Next, the Linux distributions list. Ubuntu, it came into existence in 2004 by Canonical and quickly became popular. Canonical wants Ubuntu to be used as easy graphical Linux desktop without the use of command line. See, in most educational institutions use the Ubuntu. Ubuntu is the next version of Debian and easy to use for newbies. It comes with lots of pre-installed apps and easy to use repositories, libraries. Next, Linux Mint. Mint is based on Ubuntu and uses its repository software, so some packages are common in both. Earlier, it was an alternative of Ubuntu because media codecs and proprietary software are included in Mint but was absent in Ubuntu. But now it has its own popularity and it uses Cinnamon and Mate desktop instead of Ubuntu's Unity desktop environment. Next one is Red Hat Enterprise or CentOS. Red Hat is a commercial Linux distributor. The three products are Red Hat Enterprise, Linux and Fedora, which are freely available. It supports till 7 years after the release, whereas Fedora provides faster update and without any support. Red Hat uses trademark law to prevent their software from being distributed. Community project that uses Red Hat Enterprise Linux code but removes all its trademark and make it freely available. In other words, it is a free version of RHEL and provides a stable platform for a long time. Fedora. It is a project that mainly focuses on free software and provides latest version of software. It does not make its own desktop environment but used upstream software. By default, it has GNU ME3 desktop environment. It is less stable but provides the latest stuff. Next one is Linux licensing. Linus Torvalds has given Linux kernel license to GNU General Public License, that's GPL version 2. GNU makes sure that any software source code licensed under it have to make originating source code open and freely available to all its users. Freely doesn't mean by cost, but it means that it's freely available to users that distributes and modify the code. Users can modify the code. We have discussed introduction to operating system, Linux architecture, difference between Unix and Linux, the features of Linux, then Linux distributions. With this topic, I conclude this session. Thank you.